25.5, 25.6, transverse waves and longitudinal waves. Section 25.5, transverse waves. Suppose you create a wave along a rope by shaking the free end up and down as shown in figure 25.8. In this case, the motion of the rope, shown by the up and down arrows, is at right angles to the direction in which the wave is moving. Whenever the motion of the medium, the rope in this case, is at right angles to the direction in which the wave travels, the wave is a transverse wave. Waves in the stretched strings of musical instruments and upon the surface of liquids are transverse. As chapter 27 will show, the electromagnetic waves that make up radio waves and light are also transverse. Let's look at the figure 25.8. The string wiggles up and down and the wave travels horizontally. They are at right angles, perpendicular to each other. That's a transverse wave. 25.6, longitudinal waves. Not all waves are transverse. Sometimes the particles of the medium move back and forth in the same direction in which the wave travels. The particles move along the direction of the wave rather than at right angles to it. This kind of wave is a longitudinal wave. Both transverse and longitudinal waves can be demonstrated with a loosely coiled spring or slinky as shown in figure 25.9. Here's figure 25.9. Both waves transfer energy from left to right. When the end of the coiled spring is shaken up and down, in the top picture, a transverse wave is produced. When it is shaken in and out, in the bottom picture, a longitudinal wave is produced. This top picture is transverse. The bottom picture is longitudinal. A transverse wave is demonstrated by shaking the end of a slinky up and down. A longitudinal wave is demonstrated by shaking the end of the slinky in and out, like forwards and backwards. In this case, we see that the medium vibrates parallel to the direction of energy transfer. Sound waves are longitudinal waves and will be discussed in the next chapter.